Hello, pre-calculus student. This video is for chapter 5.2, unit circle, sine and cosine function. So in this video, we're going to define two functions called sine function and cosine function. These two functions are called periodical function or periodic function, where you input your input and then the output will be cyclical, meaning after a while, the function go back to the same number, which cannot be achieved through polynomial or exponential function. And the definition of sine and cosine function, in case you have heard about it, is through right triangle in the past, but we are trying to define this function using unit circle, where the input is an angle in standard positions. So some prerequisite things before we define the sine and cosine function is the 30, 60, 90 right triangle and also isosceles right triangle, which you should have learned in geometry. What happened is if you draw a right triangle where one angle is a 90-degree angle, I think the right isosceles triangle is easier to understand. Then you have this right angle, and then the other one is isosceles, means they have the same angles. If they're the same angle in geometry, we say that they also have the same side. This two leg would be the same. And then the hypotenuse is C. And based on Pythagorean theorem, the side length would be A, and root 2A. Meaning, if you have a 45, 45, 90-degree triangle, if for some reason people say that, oh, one of the leg is 4, the other needs to be 4, and this would be 4 root 2, right? Or if I say, oh, I have a smaller one, this is 2. So what are these two lengths? So what happened is these are found by dividing by root 2. So we would say, oh, this is 2 divided by root 2. And this will be 2 divided by root 2. Okay, so they are related by a template of the leg being A, the hypotenuse is root 2A. And if the hypotenuse is whatever length it is, then the other one would be the length divided by root 2. So this is called the template of a 45, 45, 90-degree triangle. The other one is the 30, 60 right triangle. What happened is if you have a equilateral triangle, that means all sides are equal, and you cut them into two halves, you would have a 30, 60 triangle, because in an equilateral triangle, all the angles are 60 degree, right? So at least we know this is 60, this is 60, and then the line that cut the equilateral triangle into two halves will cut this angle into 30 and 30, right? So you will have two 30, 60 right triangle. And the template for them would be if the short side is the one that's facing the 30 degree is A, then the because you will have 2A, right? 2A. Then the hypotenuse is 2A because it's equilateral. And then the height, if you use the Pythagorean theorem to calculate it, is A root 2. So meaning if I erase this, let me see if I can erase this part, right? If I erase half of it, so I get half of it. This is a 30, 60 and a right triangle. This is A root 3. Okay, so A to A root 3. So that's the template of a 30, 60 triangle. Meaning if for some reason I have a 30, 60 triangle, I don't draw it good. It should be much shorter. If the short side is 3, then this would be 6, double of the short side, and this would be 3 root 3. And if I have, like for example, this is 8, then this would be half of it, it would be 4, and this would be 4 root 3. Likewise. So if you know one side of a 30-60 triangle, you pretty much figure out all the side. If you know one side of a 45-45, you pretty much know all the side. So the one that we want to know that's related to a unit circle or the definition of right triangle is, okay, is this one. So, oh, sorry. If you want to, you could go back and is this one? Oh no, I should draw it the other way because when we draw it for the unit circle, the triangle that we draw. Oh, sorry. How come it's like that? I don't want this. The triangle that we draw is always this side. So if I have a 45, 45, we want the hypotenuse to be 1. If the hypotenuse to the 1, what would be the vertical and the horizontal side? It will be 1 over root 2, right? 1 over root 2. Or if you rationalize it, it's root 2 over 2, equal to root 2 over 2. And then if I have a 30-60 triangle, so which we can do it this way or this way. In this particular case, this would be 30. I want the hypotenuse to be 1. Then this is 1/2, and this will be 1/2 times root 3, right? And in this case, I have a 60 triangle, right triangle. I also want the hypotenuse to be 1. Then I have 1/2, and this would be 1/2 times root 3, or root 3 over 2. So this triangle, or this 3 triangle, is essential for unit circle, definition of unit circle now. So what is a unit circle? Unit circle is a circle that has the center at 0, 0 and the radius of 1. So when it cut the x-axis, the point that it cut is 1, 0. When it cut the y-axis, it would be 0, 1 or 0, negative 1. And on the other side of the x-axis, will cut negative 1, 0. So this is a circle. And the equation of the triangle or of a unit circle is x squared plus y squared equal to 1. So I can draw it. Here's if I do decimal graphing, do a decimal calculator, and I write type x squared plus y squared equal to 1. Oh, y squared. Y squared equal to 1. It's a circle. You can see that it's cut the x-axis at 1, 0, and then this is 0, 1, and negative 1, 0, and 0, negative 1. So x squared plus y squared. If you want this triangle to be larger, 4, it will be the radius will be 2. If you want it to be the radius 3, you say 9. So basically this is r squared, right? So but I want a unit circle, so that means I want the radius to be 1. It would have this 0, 1, oh no, 1, 0, negative 1, 0, 0, 1, 0, negative 1. So that is what we use to define the sine and cosine function. They seems to be unrelated stuff, but they are used to define the unit circle. So how do I define the unit circle? We define a unit circle as you draw angles. You draw an angles with the initial side on the x-axis, and the terminal side would be from the origin out. It would cut the unit circle because the terminal side can be any length you want. It would cut the unit circle because unit circle is over here. Then the angle is t. The angle is t. You can draw the angle multiple times. You can draw it negative. The x value is cosine t. The y value that I cut the unit circle is sine t. So you don't calculate anything. You just say you draw the angle. For example, if you draw let me go back to the unit circle here. So if can I draw here? Oh, I don't think I can. Oh, maybe I can draw from the, yeah, from Zoom. I think I can draw from Zoom. Yeah, thickness. Yeah, let's try. So if I draw well, does it go like this? Ah, yeah, this is Zoom. Thickness. Okay, so you will draw like this, right? So this is my terminal side, and let's say this is 40°, right? I would cut a point. I say the point, oh, it's 3 and 4, right? I don't know what degree it is. So for some reason is 0.2466.8, right? I don't know if it's 40 degrees, so maybe I'll erase it. This is just T, okay. So if I say I think it's too thick. Make it, yeah. So if it is, so this is an angle theta or T, we call it T. So it cut the point on the unit circle and it's 0.8, 0.3, comma 0.3, no 0.6, 0.8, right? So then I would say, okay, cosine T is equal to 0.8, and then sine T is equal to 0.6. So in the past, when we evaluate a function output, we have to like calculation and stuff. But for sine and cosine function, you draw a picture. You look at where it cut the unit circle. The x value is called cosine of the input. So your angle is like 50 degree or 60 degree or 70 degree or 90 degree. That is the one that you get is 0.8. Then you say 0.8, the output. The y value is the vertical distance, is your sine function. So that is how you define the unit circle. I want to go back to this one. Nope. Okay. It doesn't go back. Oh, I think I have to cancel this first. Yeah. Then it go back. Okay, so this is the meaning of defining the sine and cosine function using the unit circle. Because radius is 1, you can also say the input is not an angle but an arc length. So this is the other pictures that I have. If I can say, instead of saying this t, I can say the arc length. I want to draw an arc length up to the whatever input that I want. And when I stop there in the unit circle, the x value is cosine, the y value is sine. X value is cosine t or s, y value is cosine t or s. And then you can also see that because they are x and y in the unit circle, the intersection of the terminal side and the unit circle, sine and cosine are positive in quadrant 1. If your terminal stop at quadrant 1 is positive. If your in quadrant 2, if your angles is stop at quadrant 2, your sine is positive, but your cosine is negative because cosine is x value is negative. This is negative x, but positive y. Quadrant 3, your sine and cosine are both negative, and in quadrant 4, your sine is negative because your y is negative, but your cosine, which is x value, is positive. And what about domain and of the sine and cosine function? The input, what input can I take? It's just any angle or any arc length, right? So if it is positive, that is positive angle. I can have negative angle. I can have 1000. I can have two. So it's all real number. And remember, you can input in degree for an angle, or you can input something that is no unit or any unit you want for the arc length. The range of the sine and cosine function is the highest cosine you can have because it's in unit circle is 1. So it's 1 here, right? And the lowest you can get is -1. So the range is between -1 and 1. So in the next video, we'll talk about evaluating sine and cosine function using the unit circle and the terminal sine.